Okay, so good afternoon or good morning. We will be resuming our discussion on how to compute dosages. This time, we're going to talk about how to compute dosages in IV preparations. Okay, so in IV preparations, it is different from oral medications. In IV preparations, most of the time, it is set to run at a certain period of time, meaning it is not taken all at once. The dose is distributed over a duration of time. Most of the time, it is running for at least 1 hour or 1 to 2 hours. Okay. Now, to compute the different dosages in IV preparations, you will be using different units. Okay. So first unit we have is our ml per hour. ml per hour is obtained by the total volume over hours to run. Okay. Next, you have your ml per minute. ml per minute is the total volume again over total minutes. Okay. So sometimes you need to convert ml per hour to ml per minute. So it is quite easy. Simply multiply 1 hour is 60 minutes. So the hours will cancel out and you will have ml per minute. And the last unit is your drops per minute or your GTTS per minute. Okay, so drops per minute can be obtained by your ml per minute. This is your letter B over drops per ml. So drops per ml is your drop rate. Okay, so the drop rate is it is given by the manufacturer. Not all administration sets are the same. That is why you are given the drop rate for each type of administration set. Okay. Okay, and the last unit you need to give is your drops per minute. Drops per minute is useful, or this is the most practical unit because this is directly adjustable. What do I mean? If ever you've experienced going in an hospital or being admitted in the hospital, when you see the nurse looking at your IV line or your IV meds, and you are seeing her use a button or use a scroll, she is actually adjusting the drops per minute. Okay, so she can adjust it to go faster, more drops per minute, meaning you are depleting the bag faster, or she can slow down the drops per minute and decreasing the rate of depletion of your IV bag. Okay, so drops per minute, you can actually get drops per minute by drops per minute by a simple formula. Okay, you have your volume to be infused in ml over time for solution to be infused. It should be better if you actually have it in minute. Okay, then you're going to multiply this whole with your drop rate. Okay, so your drop rate is in drops per minute. ml, drops per ml. Okay. So where do you get your drop rate? Please remember that your drop rate is given by your manufacturer. It's either your manufacturer or your product insert. Okay. Please observe the units when I cancel them out. ml, ml. The final unit, you will have drops per minute. Okay. So with that, let's get started with the sample problems. Okay, I just checked if I was still recording. Okay, the first sample problem. The physician ordered 500 ml of a special electrolyte solution to flow at 50 drops per minute. The pharmacy has called how long will it take before the patient would need the next bottle. Administration set is 15 drops per ml. How long will it take to infuse the bottle? Okay, so what is being asked? What is being asked is actually how long, meaning you are being asked the duration of time. Okay, so you have your 50 drops per minute. This is your drop rate. I mean your infusion rate, drop per minute. You have your volume, which is 500 ml. What is missing is time. Let's put it in minutes so it can be easily cancelled out. And the next one is your drip rate or your drop rate from your administration set. It is 15 drops per ml. Okay, so let's rearrange the formula. 50 drops per minute times ml over 15 drops equals 500 ml over x minutes. So I will rearrange the formula here. X minutes equals 500 ml over 50 drops per minute times ml over 15. X minutes is okay, so you should get your calculator and calculate. You can pause the video if you like to get it for yourself. So it would take 150 minutes. So if it is an hour, you need 2.5 hours. So you have to inform the pharmacy that the next bottle would be needed after 2.5 hours of starting the infusion therapy. Next. So the order is garamycin, 60 milligrams, IV piggyback every 8 hours. What is available is Garacin, which is the brand, 80 milligram per 2 ml ampules. So the administration set is 10 drops per ml. So the first question is, how many ml of garamycin, this is particularly the garamycin which is the available ampule, will you need to prepare to equal the dosage ordered? And you are to dilute the medication in NSS to make a final solution equal to 150 ml. What is the rate of infusion if the drug is to be administered in 1 hour? So we actually have two answers to be computed. So first one is how many ml of garamycin. The next one is what would be the rate of infusion. So number one, how many ml of garamycin is needed? So the order is 60 milligrams. Okay, and what is available is 20 milligrams over 2 ml. So if 80 milligrams is to 2 ml, 60 milligrams would be 1.5 ml of this preparation. So you need to break the ampule and only aspirate 1.5 ml. Next, you're going to dilute the medication in NSS to make a final solution equal to 150 ml. So you're going to dilute this into 2. You are going to dilute it to make 150 ml. So if you need to administer the drug in 1 hour, how long or how fast should the drip rate be? Okay, so we are looking for the infusion rate, drops per minute. What is the final volume to be administered? 100 50 ml. Do we need to compute for the concentration? Not necessarily. We don't actually need to compute the concentration. For the reason, you're going to deplete the bag anyway. Therefore, if you dilute 60 milligrams to 150 ml, if you deplete the whole 150 ml, you will still receive 60 milligrams. Okay, and the duration is 60 minutes. The drop rate is this one. Administration set is 10 drops per ml. It will cancel out. ml 10, 150 divided by 60 multiplied by 10. You have 8 drops per minute of 25 drops per minute. So you will finish the whole solution in 1 hour with a rate of 25 drops per minute. Next, a small child is given 10 ml of 3% lactated Ringer solution, 50 ml protein hydrolysate, and 10 ml of isotonic salt solution at a rate of 100 drops at a rate of 100 microdrop per set. At a rate, I think I think they should be using a microdrop per set at a rate of 50 drops per minute. What is the running time? So, sorry. It should have been. Diba? So I will correct your slides later. But a microdrop per set is 100 drops per minute. Okay. Per ml, sorry. Drops per ml. So please refer to the updated slides. Okay. So what would be the running time? First, we need to determine the volume. To get the volume, you simply need to add all the volumes together. So that is 70 ml. The running time is missing. So that is X. The drop set is 100 drops per ml. And your the dip rate is 50 drops per minute. So let me arrange the formula. XML equals 70 ml multiplied by 100 drops per ml over 50 drops per minute. So this is actually in minute. ml drops. Final amount would actually be your. So sorry. So I'm gonna reverse this one so you could see it clearly. So previously it was in division. So minute over 50 drops. So you can clearly see that the drops cancel out and the final unit is in ml. Okay, 70 times 100 divided by 50. That is 140 minutes. So the running time is 140 minutes. Okay. Now, as you see, these types of problems are relatively easy as long as you memorize the formula and you know where to get the proper data. Next, a patient suffering from acute asthma is prescribed 400 milligrams theophylline in 50 ml D5 water over an hour. If the administration set is 15 drops per ml, calculate the rate of flow. Aminophylline 500 milligram per 25 ml is available. Okay, so this one is available, and you need to add it to 50 ml. Okay. Okay. So it would not be practical to remove 50 ml from D5 water. It's not practical to remove a certain amount of fluid from D5, then add the drug. Okay. So it would be practical to simply inject the certain amount of drug in the preparation before administering it. However, in this case, since you injected more drug, which is a liquid, you need to take into consideration that the volume of your IV fluid will increase. Okay? So first is 400 milligrams of aminophylline. What we have is a dosing of 500 milligram per 25 ml. So I would actually need 20 ml of this fluid. Since there is 20 ml and it would be added to 50 ml of D5, the final volume would be 70 ml. 70 ml over an hour, or let's erase this one. Let's make it in 60 minutes. The administration set is 15 drops per ml. Okay, so the final unit would be your drops per minute. 70 divided by 60 times 15. So you have a drip rate of 17.5 drops per minute. Okay,